To start, I want to explain why apples float always in water. Like you saw in Alexander's experiment, even that I push it, the apple always comes up. Well, there are two forces in action here. That is, the weight of the apple and the force that water applies on the apple, that is, the buoyancy. For the apple not to sink, buoyancy at least equal than the weight of the apple. Now I have a potato. You know that the potato thinks, but even that there are buoyancy. In this experiment, I start by verifying the weight of potato. So, this is Newton. I'm going to put the potato in water and I weigh it again. Well, in water the weight is 0.05 Newton. The value of buoyancy is the difference between these two values. So the buoyancy is 1.25 Newton. There are buoyancy in some case that the object was put in water. Here I have a scale where the sides are equilibrated. I'm going to put this side in water. Now the scales are disequilibrated. I have to add some water in this object. Now the sides are again equilibrated. I have to add here the value of the weight of the water that was dislocated. This is the buoyancy. I have already finished. Thank you.
Hi. We want to switch two different liquids with different densities from their respective cups. We want to put the olive oil in this cup to this other cup and the water in this cup to this first cup. We don't have a third cup. We only have this cup, and a playing card. Let's see how we can do this. So what's happening? The oil is flowing up and the water is flowing down. What we had here was the fact that the difference of densities made the water flow down and the oil flow up. When we put those two liquids in contact, the one that is denser has to be under, and the one that is less dense has to be up. Now we should be able to take the olive oil out, and here we have it. We changed the olive oil that was in this cup to this cup, and the water that was in this cup to this first cup. We hear the environmentalists saying that the polar melting is responsible for the increasing of the level of the seas. We're going to prove if that is right. We have here a test tube filled with water. This water is entirely solidified. It's ice. We're going to mark the level of it. And now we are going to melt it. So here we melted the ice, and what can we see? The level of the water decreased. We have here a lower level than we had before. There was a decrease of the level. So let's see another experiment. We have water, and we are going to addict an ice cube. So let's mark the level of the water. So we've melted the water, or the ice cube, and what we can see is that there was a maintenance of the level of the water. So, with these two experiments, where there was decrease and maintenance of the water level, how can it be true that the environmentalists say that the polar melting increased the level of the seas? Actually, the polar ice is almost all outside of the water. It's not what we have here. We mark the level of the water when the ice is already inside it. In the case of the ice in all the world, we have ice that is addicted to the water. And when water is addicted to the water, we have a volume increase. The volume is higher.